Sulfur 16, the chemist still. In this experiment, we are going to learn about how to separate a mixture of ethanol and water. The method of separation of this mixture is called fractional distillation. The fractional distillation method works on the principle that the liquids in the mixture have different boiling points, i.e., water has a boiling point of 100 degrees Celsius and ethanol has a boiling point of 78 degrees Celsius. Therefore, when the mixture is heated, the liquid with lower boiling point, that is ethanol in this setup, evaporates before the liquid with higher boiling point, which is water in this setup. Note from the previous information, the boiling point of ethanol is lesser than that of water. As we are setting up our apparatus of this experiment, let us discuss what is fractional distillation. Fractional distillation is the method used to separate a liquid from a uniform mixture of two or more liquids but of different boiling points. One of the ways to check the purity of the separated liquids is to measure their boiling points, e.g., pure ethanol boils at 78 degrees Celsius. But this method has limitations to achieve 100% of ethanol. Therefore, a student is advised to identify those limitations. Why must water through the condenser enters from the bottom and exits at the top? The answer is, feeding from the bottom exposes the hottest vapor to the coolest water, maximizing the heat transfer. If the water enters through the bottom tube of the condenser will always be completely filled with cold water, which ensures efficient cooling. Therefore, the outer jacket of the condenser is fully filled with water for efficient condensation of the vapor. The initial temperature reading of the experiment or the initial temperature reading of the room is 30 degrees Celsius. During fractional distillation, the liquid in the heated round-bottomed flask vaporizes and moves up through the condenser, where the vapor is cooled and condensed back to liquid droplets that flows down into the receiver flask, which is a conical flask for this setup. Someone is asking why there is no vapor formed in the flask, but the flask is being heated. The answer is very simple. There is insufficient energy input to cause adequate vaporization of the mixture. Therefore, we must increase the amount of heat in this setup. As we can see, the temperature of this experiment is increasing steadily. And even the mixture vaporized and the vapor rised up through the condenser. Since we discussed earlier that ethanol has a lower boiling point than water, therefore it will vaporize first and the ethanol vapor is then cooled and condensed inside the condenser to form pure liquid known as distillate. Let us try to prove that the distillate is ethanol, not water, at this moment. Using a spatula, we can pick a small amount of the distillate and we subject it to fire. You see, it burns. Can water burn? No. Why is water used as a coolant in condenser, not any other liquid? The specific heat capacity of water is higher compared to that of other liquids. By the way, what is specific heat capacity? Specific heat capacity is defined as the amount of heat required to raise the temperature of the system by 1 degree Celsius. Due to high specific heat capacity of water, it can absorb large quantities of heat. This results in cooling of the system. As we can see now, the temperature of the system is beyond the boiling point of ethanol. It implies that ethanol is done. Therefore, what is coming as the distillate is now water. The temperature reading is now increasing steadily to 100. We can use the same trick to prove that the distillate now is not ethanol but it's water, by picking a small amount of distillate using a spatula and subject it to fire as shown. You see, it does not burn because water does not burn in air. Share this video to your friend. Don't forget to subscribe to my YouTube channel. This is Sulfur 16, the chemist. We meet.